Okay, this is your workbook, exercise 13.1 on the reflection of light. The first question is rather easy. You just have to refer to the physics textbook and you can get the answer. For AB, this line is the normal and is perpendicular to the mirror. For RB, this is the incident ray whereby the ray hits the mirror. And BS is the reflected ray. MN obviously is a mirror. And the angle of incidence is RBA, between the incident ray and the normal. Okay, so this is the angle. And angle SBA is the angle of reflection. Okay, one thing to note, angle of incidence equals to angle of reflection. Okay, next we move on to question 2. Question 2 state the laws of reflection. This can be found in your physics textbook also. The first law, in the incident ray, the reflected ray, and the normal and the point of incidence all lie in the same plane. Second law, the angle of incidence is equal to the angle of reflection. Okay, so this is important in your exam. And the third question, the registration number of a car is QBE6825R. And write down the number as seen in the rear mirror of the car in front. This one requires a bit of coordination, and of course, okay, you must know that they are laterally inverted. And this is the answer here. For question number 4, the question says that complete the diagram on the right to show the path of the ray as it is reflected by the two parallel mirrors. Okay, so name the device that uses mirror arranged in this way. Where can you use this device? Okay, so I will answer this first. This is actually a periscope and is used in submarines when you need to look over high obstacles such as a wall. And this is usually used in the army, whereby they want to peep at the enemy locations. Okay, so over here, the important thing is to note the angle of incidence, and from the angle of incidence you know the angle of reflection. Okay, so over here, this is the answer, and the two parallel mirrors, okay, is this way. So as the light ray hits the mirror, it is actually 45° to the mirror. So the angle of reflection is also 45°. And when it comes here, you can also draw the normal. Okay, this is not very good. Over here, it will be 45, and the angle of reflection will be 45°. To really draw the reflected ray, you have to use a protractor to actually measure the angle. And when it hits here, you have to measure the angle again, 45 and 45. Okay, so this is the answer for question number 4. Okay, this question 5. If the angle between an incident ray and a plane mirror is 35°, and part A, they're asking you for the angle of incidence. Over here, the answer is 55. For part B, the angle of reflection is also 55°. For part C, this is not a very good question, so you do not have to answer this. So to represent this graphically, okay, I will draw it over here. This is a plane mirror, and when the incident ray hits the plane mirror, this angle is 35°. So when it moves away, this part should also be 35°. And what is the angle of incidence? So over here is 90 minus 35. So this one should give you 55°, right? And over here, if this angle of incidence is 55, then the angle of reflection is also 55. And now let's move on to the next question. Question number 6. The figure below shows two plane mirrors set at an angle 100° to each other. A ray of light strikes one of the mirrors at an angle 45 degree to the mirror. So this can be found in your workbook. So when it strikes the mirror at 45, then we know that okay, by through this normal, we know that the angle of incidence is also 45. Okay, so over here, this is the plane mirror. These are the plane mirrors. Okay, so when it hits it, it's at 45, and let's draw in a normal. So we know that angle of incidence should be 45 because 90 minus 45 is 45. And then after that, you can draw in the reflected ray. The reflected ray is also 45 degree. Okay, and over here we know that is 45. And since the angle here is 100 degree, then the angle here should be 35 degree. This is question 6. The figure below shows two plane mirrors set at an angle 100 degree to each other. A ray of light strikes one of the mirrors at an angle 45 degree to the mirror. So this is the 45 degree. Now in part A, what is the angle of incidence? Recall the definition for angle of incidence. Angle of incidence is the angle between the incident ray and the normal. So what is the angle here? It's 45. Why? Because it's 90 minus 45 degree. Part B, redraw and complete the diagram below the path of the ray after reflection at both mirrors. So over here, this is the answer and it's not very clear. I'm going to redraw it and explain it at the same time. So these are the two mirrors. The ray strikes the mirror at 45 degree. But remember, this is not the angle of incidence. To find the angle of incidence, you have to draw in the normal. And angle of incidence is actually 45 because 90 minus 45 is 45 degree. So we know that the angle of reflection is also 45. And over here, obviously, okay, 90 minus 45 will give you 45 again. Okay, so over here we know that the degree is 100 degree. So what is the angle over here at this side? It's quite rather easy because this is a triangle and we can make use of the properties of a triangle. In a triangle, the total angle is 180 degree. So 180 minus 100 minus 45, and this will give you 35 degree. So over here is 35 degree. And how do we find the angle of incidence? So we draw in the normal again, and 90 minus 35 will give you 55 degree. And we know that angle of reflection will be equal to the angle of incidence. So this will also be 55 degree. So this actually completes question 6, which is part C. Calculate the angle of reflection at which the ray leaves the second mirror. Angle which it leaves the second mirror. Okay, so it's 55 degree.